Okay, so this paper started actually in a different project because I read the series of papers by Philip Berghofer where he made basically two claims. So first is that philosophers should investigate the quantum reconstruction program, or at least take this more seriously. And second is, once you analyze what the quantum reconstruction program is doing, then it's more convincing that quantum theories or the quantum theories that are actually reconstructed in this program are in some way more convincing or better than the theories that are not part of that program. So I wanted to reply to that, and the reason why I make now the connection between the quantum reconstruction program and the ontological model framework is that the quantum reconstruction program always says something like, psiontic theories don't fit in there, our theories are better than psiontic theories, and so on. So at first seems to be that they only want to make a distinction between certain type of theories, but I think there's an even deeper issue, namely that there is a certain kind of rejection, I think, of the ontological model framework to a certain extent. And the referees told me when I made this in somewhere in this first paper implicit, that it's not obvious that actually I can compare these two programs because they are just different programs, they're in a different business. So therefore, the goal of this paper is to show that actually they are doing something very similar. They have a similar goal, but in a certain way they are actually not compatible. At least if they're compatible in a very narrow realm. Good. So the problem is why we come up with these different kind of programs is that the quantum formalism is successful. So it is that the application of the mathematics in quantum theory gives good empirical predictions and good ways for intervention, so therefore we can make good experiments, we can build technology and so on. Here everything is done in relativistic quantum mechanics, but you can just generalize that. I think that is not the big issue. But the problem is that the quantum formalism does not tell us why it is successful. At least if you think that this is a problem, then you want to answer that why the quantum formalism is successful in the first place, because the physical theory should be more than just merely empirically adequate, should give us more than just that, a certain kind of algorithmic methods to make empirical predictions. And there are certain kind of approaches for a solution. I mean, you can just say, okay, I'm a pragmatist. I think the only thing that is important are these kind of pragmatic consequences in making predictions or technology and so on. I'm not so concerned about where this formalism comes from, where it's grounded and so on. That's fine. If you think there is something to explain, you want to derive the formalism, formula that you use in making the contact to the empirical world in some way. And this is actually what these two programs actually want to accomplish. So the quantum reconstruction program and the ontological model framework do that, in my opinion at least. This is explicit, so if you read the papers, the quantum reconstruction program is always explicit that we want to derive the formulas of quantum mechanics from in a certain way. I think that that's also done in the ontological model framework. The issue is just that the debate shifted not from deriving the quantum formalism in a specific way, but only to pick one part of the ontological model framework, namely the categorization between psiontic and psi-epistemic, and then we forget somehow the rest of the framework. So this is what I want to argue for, that the ontological model framework has also the goal in justifying and deriving the quantum formalism. So if you look at papers that say something about the ontological model framework, you find a phrase like that in Berghofer 2024, that the ontological model framework aims to purge quantum mechanics of all operational notions. And in another paper, author is right here, Christian, I think you wrote with Andrea that the primitive notion of such ontological models consists exclusively in preparation procedures and in measurements. And then you think, okay, wait a minute, there's in some way, we only talk about, operational notion that in one sense there's a primitive operational notion in the ontological model framework. So what's actually going on? So the important thing is in the original 2010 paper, which is a very rich paper. There's a lot of different remarks and ideas and so on buried in the paper. Harrigan and Spector say the following: that in an ontological model of an operational theory, the primitive of description are the properties of microscopic systems. So what they say is we have a certain kind of operational theory, whatever this kind of theory is. And operational means that it's mainly used for justifying preparation and measurement procedures, and there's no story about where these kind of how you microscopically justify or so on their preparation and measurement procedures. And then they say we want to connect that, so we want to have a kind of a justification for that, and then they present just this integral. I don't know whether we need to take this so literally, but the idea is that we have here on the left-hand side the statistical probabilities that come from the operational prediction. So M stands for measurement, and P stands for preparation, and then the K's are certain kind of results. And the idea is that these things should come from, namely from what they call an ontic state, namely from in this symbol it's lambda. So everything that is captured in measurement procedures and in preparations and in the statistics of these measurement results, at the end of the day, it should come from the ontic state. But this ontic state is then introduced as in a different level, or as part of a different kind of theory or so on. Once you say, okay, I just have an operational theory. So these are these two levels that they introduce. And then after that, then they come up to ontic, to epistemic, and then statistical interpretation, and Einstein, and so on and so forth. But this is the framework that everything is actually formulated in. So in the ontological model framework, there is an ontic state lambda. The ontic state has objective properties. These properties determine the probabilities and outcomes of measurement and preparation procedures. And in this sense, lambda explains the quantum formalism and the quantum phenomena. Good. And now is the question, how do these distinctions of psi-epistemic and psi-ontic and so actually fit in? And they fit in because the wave function is in some way a middleman between the ontic state and the probability. So just a simplification. Normally the actual definitions are done with respect to certain probability distributions over the ontic states. That's not so important for this. What I want to say in just distinguishing between ontic and epistemic, the important thing is that what I want to emphasize is that given an ontic state and the wave function is psi-ontic, there's just one wave function that correctly describes what this ontic state is. And for psi-epistemic, that given an ontic state, it's possible that two different wave functions describe that ontic state. I mean, there's certain kind of technical difficulties that you can represent the wave function in different ways, but taking these technical difficulties aside, this is the basic idea. So for any ontic state lambda, that at most one wave function that correctly describes its ontic state, then it's psi-ontic. And some ontic state lambda, if it has more than one wave function that correctly describes its ontic state, then this is epistemic. And here we don't have any kind of further definition or so on about ontic and epistemic. These are just formal notions about the relationship between the wave function and the ontic state. The question is now, why do they talk about ontic? Why do they talk about epistemic here? That's a next step. I mean, the ontic should be a bit more clear, because then in some way the wave function represents exactly the object or the properties of this ontic state. So there's in some way more like redundancies or so on in there. Here there's a kind of a disagreement. So there you can say a bit more why that could be something epistemic. So let's dig deeper into this epistemic. That's a distinction that I take from Tim Morton in his quantum theory textbook. He divides epistemic into psi-statistical and psi-creedal. And that is important because sometimes it's said that epistemic really means epistemic in the sense about knowledge. And here's a counter-example of a theory, of a wave function that is psi-epistemic, but it's not in some way, epistemic, namely psi-statistical. And psi-statistical works like that. I have just a kind of a picture of this. So if in a psi-statistical theory the state of a system is defined by being prepared in a certain kind of ensemble. So these quantum systems all have states spin up because they are part of the ensemble of being spin up in x direction, and then we have another ensemble that is prepared in z up direction, and b, in this quantum state means that each of these individuals is part of the ensemble. Good. So we know that if a wave function is epistemic, it's possible that there's one state that is described by two different wave functions. In this case, it's possible that there's one of these objects that is actually correctly described by the other wave function. So we can swap like that and say, okay, this is the one that is x up and z up at the same time. And these are the ones, actually, this kind of ontic states are the ones that make a problem for the PBR theorem. That therefore that's important. I mean, the original paper or the first version on the archive of the PBR theorem is actually about a statistical interpretation of quantum mechanics. Then it was later extended in the final version to psi-epistemic. Good. Here's the kind of thing that I think many have in mind, what this means to be epistemic, namely that two different agents may assign different wave functions to that quantum state. And the thing is that what's important is that it's not about like pure knowledge or something purely epistemic. It's about the kind of interaction between what an agent has, or pre-knowledge or whatever, and assigning this kind of state to that physical object. So it's not like purely epistemic. It's referring to that object given certain kind of either priors or so on. I mean, the details depend on the specific quantum theory. That is not part of the model. Okay, so let's summarize. So the ontological model framework reduces the quantum formalism to properties of ontic states. The ontic state is the constructive base for the quantum formalism in this framework, and the wave function is the middleman between the constructive base and the probabilities for preparation and measurement procedures. Good. So let's move on to the quantum reconstruction program, and I have a couple of quotes that make it understandable what is actually happening here. So in some way, in some presentations, it is presented that Rovelli's paper on relational quantum mechanics is somehow the foundational document for the quantum reconstruction program, because here he makes a comparison to special relativity. So he says that quantum mechanics will cease to look puzzling only when we will be able to derive the formalism of the theory from a set of simple physical assertions, postulates, principles about the world. And therefore we should not try to append a reasonable interpretation to the quantum mechanics formalism, but rather to derive the formalism from a set of experimentally motivated postulates. This is the last part. This is the important key sentence, that we don't understand and have a good grip of quantum mechanics unless we do exactly that and derive the formalism from a set of experimentally motivated postulates. So in the paper then suggests, okay, why not these kind of postulates? With n particles, they the evolution of the wave function is called the Schrödinger equation, and then also we have a nice equation for the n particles. And this is not what's meant in this quantum reconstruction program. So even though you may argue that these three axioms are in some way not empirically motivated, these are the axioms of bombing mechanics, and the quantum reconstruction program actually does not want to derive or does not accept these axioms as a kind of a proper reconstruction. The question is then, why is that the case? And I find this quite interesting, because if you just think about this very general claim or demand by Rovelli, just postulates that are experimentally motivated in some way, you can just reconstruct almost any physical theory, because the physical theories there are, they make empirical contact, and they're not coming out of the axioms do not come out of the blue. In some way, they are used to make, empirical contact with the world. So what's going on here? What is the demand? There are demand, are further constraints on the axioms. So this is by Berghofer, what he is saying about the further constraints. So assuming that informational reconstructions are particularly helpful in elucidating the quantum formalism, the objectivists, namely the ones like the Bohmians or the ontic theorists, is in the following inconvenient position. Regarding their interpretation of quantum mechanics, they want to avoid all operational language, but if they wish to derive the formalism from simpler principles, they need to use information theoretic principles. This is what we see a lot in the quantum reconstruction program, that there's a recourse to principles that are formulated in terms of information theory. And why information theory? Here's a quote by a very nice paper by Koberinsky and Müller that's explaining a lot what is behind the quantum reconstruction program. So they say reconstructions represent a challenge for existing ontic interpretation. So you have it here of quantum theory by highlighting a relative deficiency of those interpretations in terms of their explanatory power. So the quantum reconstruction program wants to derive the quantum formalism by saying, okay, if we reconstruct the theory, it has a higher, bigger explanatory power than the other theories, namely these ontic theories, for example. And then you may ask, okay, what is explanatory power? What do they mean by that? Surprisingly, here's an answer. Surprisingly, there's not so much written in the philosophical literature. There's just a couple of papers that I find interesting, but I thought there was much more. Anyway, but here's what Koberinsky and Müller say. So none of quantum mechanics, evaluating quantum theory or collapse theories fill the explanatory role of a principal theory. So for example, evaluating quantum mechanics or quantum theory does not start with a broad general framework of theories of many worlds, put simple principles on top of that, and prove that quantum theory is the unique theory of many worlds that satisfies these principles. So this is the idea. So the requirement is that these principles fulfill the criteria of being a principal theory, and then in this principal theory, then you derive the quantum formalism, and it turns out that the information theoretical axioms provide exactly this kind of framework for qualifying as a principal theory, and then you have a successful reconstruction. So it would actually look like that the connection between the quantum reconstruction program and the ontological model framework. So while in the ontological model framework we start with a constructive base, namely the the ontic state. Then you want to derive from the properties of the ontic state the quantum formula in some kind of bottom-up way. The quantum reconstruction problem goes the other way around. It starts with particular principles, and then from these principles derive the quantum formulas. And why should you do that? I mean, here, again, this is somehow the kind of standard way of building up physical theories in general. They want to challenge that and say, okay, we do that actually because it is a better way of deriving the quantum formulas, and because it's just more explanatory than the other way. Good. So is that scheme compatible or not? So do they reach the kind of same reconstruction or the same kind of ontology or so on? And as I said, in principle, I think the means are there, but in practice, actually not, because at the end, the reconstructed theories, they fundamentally disagree what they tell us about how the world actually works, in contrast to the theories in the ontological model framework, especially the ontic theories. So I want to introduce another notion. Pseudoxastic theories is from also a paper by Berghofer. It's actually a known kind of property that hasn't had a name yet. So he writes that a pseudoxastic interpretation says that the wave function neither represents an ontic state nor the knowledge about the underlying ontic state, but the agent's degree of belief. So what he means by that is that there are theories that are neither psi-ontic, neither psi-epistemic, but something else. So the ontological model framework actually leaves out a very big part of possible possible quantum theories. So in other words, you can't define these pseudoxastic wave functions or theories within the ontological model framework. It's actually a notion, even though it's using a kind of formal way of describing wave function within the ontological model framework. It means something outside that model. Whether that's the right or good name, I don't know. Maybe idealistic would be better, or something else. I'm not so sure, because it's again degrees of belief. Again, you can ask degrees of belief of what. Is there something that these degrees of belief refer to or represent or so on? Anyway, good. So when we extend the ontological model framework, we have then psi-ontic theories where we have this unique relation between the ontic state and the wave function. Then we have a non-unique relation. And then these pseudoxastic psi-idealistic theories, actually they don't make the connection at all. So they want to say whatever the wave function refers to, namely in terms of the probabilities and so on. It's not about the ontic state. It's not about this kind of objective physical world that has these physical properties. So when you read, so I find it interesting when I read the paper by Kobylewski and Müller, that they say, good, we have a certain kind of reconstruction, but the reconstruction is still not complete. So once you have a reconstruction, there is still a question of what is the proper ontology. So we can still do some kind of metaphysics. And what comes out of that analysis is that there's a certain kind of overlap. So in some way, these kind of psi-creedal theories, they are allowable wave functions within the quantum reconstruction problem. So in one sense, you want to have these kind of theories like cubism, and I think also related quantum mechanics fits in there. But that's also allowed that certain kind of reconstructions are these kind of psi-creedal theories, or maybe you can call them different. At least they are not these psi-statistical. So there are a certain kind of subgroup of psi-epistemic theories that are not psi-statistical, but closer to something like that. So then I just ask the question: so why is, because here you have to get, you have to introduce this ontic state. So why is in this case the ontic state something good or allowable and not here? That's because it's always said we don't want to do something like that because that's not explanatory. So maybe not about the ontics, maybe it's really about, you have to get these specific principles or so on. I have an idea, so I think maybe in some follow-up work, I think that I have an idea why they do that, because I think underlying all that is a specific way of what it means to be more explanatory. And I think at the end of the day, what is happening is that the quantum reconstruction program wants to tell us this kind of counter-legal cases, not only about the counterfactual, so how the world could have been given the specific law that we have, but also what are the allowable laws given the principles. So it's I think this kind of contrast between counter-legal cases, but that's not really explicitly justified or explained, but I think implicit in all the work. Good. So let me conclude. So in principle, the reduction of the quantum formalism in the quantum reconstruction program is compatible with the ontological model framework, but in practice, I think they are almost mutually exclusive due to the different ontological and methodological assumptions. Thank you very much.
Now, Patrick Fraser will bring his comment on talk data.
Do you need the...
Oh, no, it's okay. Yeah. First of all, thanks for a very nice talk. I think that this is sort of answering some stuff that's kind of quite important, because in the sort of philosophy of quantum mechanics, there's a lot of sort of well-entrenched issues that we've kind of run around the laps of the same course over and over again, and quantum foundations has moved on from some of those issues, and things like quantum reconstruction and the ontological models framework are kind of contemporary issues that are of foundational significance but lacking philosophical engagement. So it's really great to see sort of more work being done to sort of sort out how our philosophical understanding of quantum mechanics should be informed by these kinds of developments. So that's really great. So just to sort of summarize and recap some of the core features of what's going on in this talk, there's these two different programs, the ontological model framework and the quantum reconstruction program, that are clearly related to each other in some kind of important way. They seem to have fairly similar goals, in at least prima facie, but it's not entirely obvious how the presuppositions that go into how they address these kinds of goals are supposed to work with one another. And I take it that a large part of what's at issue in this particular project is to sort of disentangle the relations between not just how these two frameworks are trying to sort of achieve similar goals, but also the differences in what they take as their starting points for doing so. So loosely speaking, the ontological model framework sort of primitively posits some collection of ontic states, says, these are the physically possible configurations for the objective world, and then tries to come up with an account of how we can think of the formalism of quantum mechanics as somehow the sort of state space of quantum mechanics as sort of mapping onto that collection of ontic states. And there's various options that can come out of that. It could be the case that the quantum states just are the ontic states, so that's something someone might hope for, in which case you'd have a kind of psi-ontic view, or it could be that quantum states are probability distributions over, it could be that quantum states are probability distributions over the ontic states, in which case they would not, literally speaking, correspond to ontic states. They'd somehow inform us about them, but indirectly so. And these are what we call psi-epistemic states. And then we get the further subdivision. If you think of quantum states under the guise of psi-epistemic reading, then it could be the case that they are states that describe arbitrary ensembles of physical systems, or it could be the case that they describe the particular kinds of ensembles of systems that we actually engage with and interact with and manipulate. And that sort of carves up the psi-statistical and the psi-creedal variations of psi-epistemic states. Something I think that's helpful to clarify some of what's going on here is that it's not like you can have one quantum state that's a psi-ontic state and another one that's psi-epistemic. Really what's at issue are like the different ways we can conceive of the role of quantum states in general. So that's an important feature of this. And the ontological models framework is just generally seeking to disentangle how we should conceive of quantum states, viewing them as sort of aiming at latching on to the underlying ontic states of the world. Okay. The quantum reconstruction program, by contrast, starts from a very different vantage point. It doesn't start by saying, okay, let's talk about this unstructured collection of the sort of basic physically possible configurations of the objective world. Instead, it starts by saying, let's try and figure out why quantum mechanics looks the way that it does by sort of reconstruing it in terms of information theoretic principles. And when you frame quantum reconstruction in that kind of light, then it sort of straightforwardly starts to get a kind of agentive gloss. What do I mean by this? When you start talking about information theory, you generally are thinking about something like, agents that are manipulating things in some way, they're transforming them, and they're carrying out information processing tasks where information is kind of intentionally directed by them to the things that they're manipulating. And so when you think of quantum theory as an information theoretic theory, you sort of tend to feel a compulsion towards thinking of it as an agentive theory. It's a theory about, how a thinking subject thinks about quantum systems and how they represent them and their beliefs about their behavior, rather than being a theory about sort of objective things in the world that are sort of agent independent. Now, with this kind of view in mind, the argument that shows the purported incompatibility of these frameworks basically proceeds by noting that the ontological model framework seems to sort of favor or frame quantum theory as a theory that's targeting sort of a description of the objective structure of the world, whereas the quantum reconstruction program sort of frames quantum theory as an agentive theory about how the world appears to subjects. And if you take that difference seriously, then of course you can't really do both at the same time. They're kind of aiming towards different goals. They make very different presuppositions. And this is ultimately what Hubert uses to conclude that most of the options that are available on the ontological models framework for how to conceive of the quantum state are unavailable if the quantum state is understood as a state appearing in a quantum reconstruction program. And you're really only left with the Psi-Friedel states. So there's lots of different things that Hubert is talking about here, lots of different arguments that he's making. I really want to focus just on this distinction between agentive modalities and more broadly physical modalities, because I think that there's some really important things that happen when you keep track of that kind of distinction. And I think that if you are really careful to distinguish between these two kinds of thinking about the relevant modalities operative in contemporary physics, the picture isn't quite so straightforward. So I'm going to call agentive modality just that which is possible insofar as some acting agent could make it so. And I'm going to call physical possibility what could happen in the physical world, whether brought about by an agent or not. Okay, so physical modality is in a sense strictly broader than agentive modality if you're not an idealist. So if you allow that there are physical goings on that agents have nothing to do with, there's physical possibilities that are not agentive possibilities. And really what's at issue here is what kind of modality we are attributing to this sort of modal scope of a physical theory in these two frameworks. And central to the argument that's been made is that the ontological models framework construes the content of quantum theory in terms of this very broad notion of physical modality, whereas the quantum reconstruction program frames the operative modality of quantum theory in terms of a much narrower agentive modality. And this is what creates the tension that Hubert identifies. Now, I want to push back against this. I don't think that this is actually fair. And there's kind of two directions that I don't think this is fair. So on the one hand, I don't think that the ontological models framework requires a reading according to which it has this fully broad modal scope. And secondly, I don't think that the quantum reconstruction program has to be read as having this really narrow agentive scope. I think actually it's more faithful to read what the quantum reconstruction theorists actually say as pertaining to a broadly physical modality instead. So first, let's suppose, for the sake of argument, that the idealists or the participatory realists or the cubists are correct, and that all there is to the world are thinking subjects that form beliefs about things, and they poke and prod stuff, and they have expectations, and they interact with each other in some way, and that's it. There's nothing else. So there's no material stuff, it's just this agentive stuff. If you make that kind of supposition, that carries ontological consequences. That affects what exists. In particular, you don't have these material things appearing in your ontology. So if you think of an ontic state as being just a possible configuration of the things that exist, if you adopt a kind of idealist or participatory realist ontology, you've changed what you mean by ontology in a way that changes what you should think of as being an ontic state. And so if you take quantum states to just be the states of agents' beliefs about things, but you've taken the world to only contain those kinds of objects, then quantum states thereby become ontic states. So in a sense, even if you sort of want to make this sort of agentive narrowing, the ontological models framework, the ontological models framework is still perfectly applicable in that kind of case. Okay, granted that's maybe against the spirit of the project, and so I don't take that to be a very strong argument, and I could very well be convinced that that's not the way to go. But I think the stronger argument, and the one that's much more relevant to this, is that quantum reconstruction, in the very few philosophical discussions of it that have been carried out, is often thought of as requiring this restriction to this very narrow agentive modality, and I don't think that that's right. So, in particular, it's true that when you look at the content of a quantum reconstruction, they're always cast in terms of preparations, transformations, and measurements. Those are sort of the usual language that these formalisms are presented in terms of. But I think it would be wrong to think of those things as only referring to tasks that agents carry out in the lab. So it helps to sort of think of an illustration. If I want to adopt this kind of agentive reading, and I think, okay, what's a preparation? I might say a preparation is just anything that I can do with the technology I have at my disposal. Well, that seems far too narrow to be what quantum reconstruction is about. Maybe I should probably inflate it a little bit. Maybe it's what I could do given any technology whatsoever. Okay, well, that's also very narrow. Presumably you want it to be more like what any human agent could do given any technology that they could possibly have at their disposal. But that also doesn't seem right. You might want to say it's what any agent, whether they exist or merely possibly exist but don't actually exist, could do given any technology that they could have or could possibly have, and so on. And you can keep inflating it. And I think what you end up with is that the right way to think of a preparation is really just any way that a state could be brought about, whether by a human hand or not. And once you've used this sort of agentive heuristic to get the idea off the ground, you can kind of throw it away, and you're left with this fully objective conception of what a preparation is. And I think this is very much in step. So first of all, if you think to like Grover Maxwell on observability, you encountered exactly this sort of thing. So you might want to say something is observable just in case I can actually see it. But we want to say that things on the other side of the galaxy are observable in a full-blooded sense, even if I could never actually go there. So we want agentive notions to still have a kind of modal breadth to them that doesn't hinge on whether or not agents are actually positioned to use them. And I think this is very faithful to what goes on in the quantum reconstruction literature at the first order. So Hardy, for example, writes that when he's talking about what transformations are, he says that transformations could be due to controlling fields in a lab, for example, or simply due to natural evolution of the system. So he allows that a transformation could just be whatever the laws of nature behaving on their own bring about. That doesn't have anything agentive about it. Koberinsky and Mueller similarly say that transformations can be treated, or can be either be interpreted as computational processes or physical time evolutions in just the same way. And then we see that Masanis and Mueller say, so they talk about an experimental setup, and they say, as soon as the release button is pressed, the preparation device outputs a physical system in a state specified by the knobs. A preparation is a bringing about of some state. That's what it consists of. And So the Kiribella and Pirinodi and Dariano reconstruction stuff, that seemed more sort of straightforwardly agentive, but even they say our axiomatization of quantum theory is relevant as a rigorous result also for those who do not share Wheeler's idea of information as the origin of physics. And I think kind of most clearly on this issue, we've got Dakic and Bruckner who say our reconstruction will be given in the framework of a typical experimental situation, an observer faces in the laboratory. While this instrumentalist approach is a useful paradigm to work with, it might not be necessary. One could think about the reconstruction principles as referring to the objective features of elementary constituents of the world, which need not necessarily be related to laboratory actions. So I think all of this sort of indicates that we don't actually need to think of quantum reconstruction as having this sort of narrow agentive restriction. We can perfectly well think that the states that are posited as the outputs of preparations are just ontic states. There's nothing sort of broken about reading them in that way. And so for this reason, I kind of think, contrary to the argument that's been given, there isn't actually this deep tension between these two frameworks. So I think there's a lot of other things that can be said, but I think that it's actually, the tension is somewhat artificial. And I think it can be actually alleviated if one's careful about how they do it. So, thanks.
Thank you, Patrick, for these comments and also challenging the argument that I give. So let me reply to that. So first, to your first argument about the psiontic theories and especially cubism. So I think I write in the paper somewhere that there's a kind of a possibility if you have the kind of, idealistic metaphysics, that if you say something like a Berkeleyan idealism where there is some kind of objective reality, but the substance is just mental, but in practice everything works as if there's an outside world. If that is the case, and cubism would subscribe to such metaphysics, then cubism would be psiontic, which I then would say is some kind of a reductio because they don't want to be psiontic. But it would be a possibility. It's good that you mentioned that. On the other hand, maybe an argument like that may force us to investigate more some kind of metaphysical assumptions in the ontological model framework, because how it's introduced, it's in some metaphysically very minimal, and it focuses more on the kind of mathematical or functional relationships between the different parts of the ontological model framework, namely the ontic state and the wave function and the formalism. So maybe one, if in order to make that precise what's going on or what the requirements or the presupposition of this model is, there needs to be some more like metaphysical assumptions, namely that no, it's not like an idealistic worldview or something like that to just bar this kind of argument. Good. The second part I find also interesting, that you also bring these quotes that show us that the quantum in the quantum reconstruction program at the end there's also the reference to physical systems and measurement devices and so on, not only about experiences. And this is something that I have a little bit of a trouble understanding, because on the one hand, these theorists really want to explain how things are, but on the other hand, they want to distinguish themselves exactly from theories that are, talking about objective reality. So I have a bit of a trouble what the kind of coherent worldview is. And you also have this quote by Czesław Bruckner that does some kind of neo-Copenhagen theory that is, explicitly not about that there's this kind of, objective ontic state there, and then there's has also consequences for the weakness friend scenario and so on. So given that, I would like to know, more and so on what this kind of, view is. It could be that the reference to measurements and so on is then indexed by, okay, given that the agents perceive that it's only about the agent's perception or so on, or it's about some properties that come up from not some objective state but some other state. I don't really know. So therefore I'm a little bit puzzled what the coherent worldview is, given that at the same time these theories want to distinguish themselves from the other psiontic theories. And a last comment is, what I really appreciate is that you talk about this kind of agent possibility. I think the modal space, I think, is very important in the quantum reconstruction program. And I think it's something that is probably the most distinguishing feature, I think, because they want to expand this the modal space, and not only want to tell us what are the kind of counterfactual differences if we do this or that or so on. It's like expanding the modal space and telling us what is actually physically possible in the first place. And this, I think, needs to be digged out a little bit more, because that's also implicit in the writings of in the quantum reconstruction program. So thank you very much for these illuminating comments, and they give me a lot of ideas for thinking and implementing in the paper. So thanks for your effort.
Now the Q&A part. I have questions registered. Okay.
Thanks, it was super interesting. I had like 2 or 3 questions. So the first one is how your project relates to the distinction that Barrett makes between different levels of empirical adequacy, and he says that the scientific approaches are only minimally empirically adequate. So I don't know, it seems like you started also from that assumption. Then how it relates to Valley-Allori's distinction between constructive and in-principle theories, because she considers, for example, wave function realism to be in-principle theory, but that's in the psiontic family. Yes, and then when you distinguish between bottom-up and up-down approach, I was wondering if there is another aspect that distinguishes these 2 families that inverts the bottom-up and up-down. Like if we take them, if we compare them as to the sort of empiricism that they have. So the idea is that while the psiontic prefer to postulate an unobservable ontology and then derive the macroscopic experience from there, the reconstruction program prefers to start from physical principles that have direct connection with experience.
Okay, thank you for these questions. So first about Jeff Barrett's empirical adequacy, his argument is mainly making something precise that John Bell refers to, namely that in what way do physical theories explain how agents observe the world? Is that somehow consistent with actual agents, namely us, observe the world? So what he wants to say is that it's also mostly, I think, within the psiontic realm that in the paper where he distinguishes quantum mechanics with many worlds, that due to the particles, therefore, we have a stronger connection between what happens in the world and what the situated observers are doing. So it's more like about how rich is the ontology, and I think in this case in these psiontic theories, so that we can have a good explanation for the observations of agents. And he makes the argument that many worlds without any additional variables is in this way inferior to something like Bohm mechanics. Good. About Valley-Allori's claim that wave function realism is in some way a framework. Yeah, I think that's right. And also Alistair refers to wave function realism as a framework that is then used for, you know, different kind of further ontological ingredients, but it will not be something like a part of this quantum reconstruction program, because there are no like these kind of principles or so on. If you say, okay, I have a kind of an incomplete ontology, or have in one case I have a complete ontology if I do some kind of wave function realism in the Everettian way, but then I have, you know, certain ways of just supplementing this ontology with certain kind of local variables like Bohmian or like a mass density to do the kind of Schrödinger stuff and so on. But it would not count as a principal theory, the kind of, you know, reconstruction in the quantum reconstruction program, because there's not like these kind of, you know, principles involved. Would then bring me back, or bring me actually to the Einsteinian distinction between principal theories and constructive theories, which is actually here in the background. So in the original newspaper article, you have to say that Einstein wrote in distinguishing, introducing constructive theories from principal theories. Einstein, I think, makes a very, very humble claim, namely that there are different heuristics for theory development. And there's one sentence, I think, that is always taken as a proof that Einstein said the constructive theories are superior, because he says something like, this is when we have a constructive theory, then we say we have a complete physical description of final theory, something like that. And I think what he says there is only like a description of what, you know, normally physicists would say in, you know, deriving or having a kind of a constructive theory. Here, the debate is framed in the quantum reconstruction program with explicit reference to Einstein, and also saying that the principal theories are superior because they explain better or more what the quantum formalism is. So they go, I think, beyond Einstein and selecting the principal theories as the superior theories. That, at least in my reading of this article, I think is not so clear, and others actually say that the constructive theories are the ones that Einstein prefers. But yeah, I would also doubt that. Anything else?
There was the third point about the empiricism, like how the ontic and the reconstruction problem connect to different forms of empiricism, like observable entity empiricism. But no.
Of different. Yeah. So the thing is this. So if you have, I think the crucial question is if you start from something like the constructive base or these principles. So is there a way that they both can actually match or not? So it seems to be that in the principles, if you say in some way I don't think you like Cubism and so on, that there seem to be at some point some ontological commitments made that are then, you know, spelled out in the full kind of reconstruction of the specific theory. And these kind of ontological commitments are at the end, in most cases, not the ones that are made in the ontological model framework. And I mean, they have to be different if you don't. I mean, if you say I can at most reconstruct, let's say, these psi-creedal or psi-epistemic theories, that effectively you want to dismiss these theories too, because you would run into the PBR theorem, and they don't want to be super deterministic. So yeah, I think there's also, I mean, at some point these kind of ontological commitments have to come in somewhere, and you see that there are some made because of the final reconstruction. And in general, probably, I don't know, the kind of attitude maybe is a bit more empiricist on that side, but in some cases it will also lead to very revisionary ontologies, like in relational quantum mechanics or Cubism and so on.
Thank you. Yeah, that was super interesting. I wanted to follow up on Marie's question about construction of principal theories, and maybe asking kind of big background questions about the quantum reconstruction progress. I've always found it kind of puzzling in the assumption seems to be, well, if you can't derive your theory from principles, then you don't really understand your theory. But if you look back at the history of science, when have we ever done that? I mean, maybe you can take special relativity as a case study, but it's like the only case study, right? So it's kind of a puzzling methodological assertion. Right? Is there anything to be said to defend the quantum reconstruction program?
Good. I think that this is a very interesting point because it explicitly makes this kind of connection with special relativity, which you can then formulate that, and then later it was like reformulate it as a constructive theory, because then you have also these relativistic laws of motion, and then you can also say, okay, classical electromagnetism can fit in, so you can put in the fields there and so on, and then we can derive the two axioms, let's say, from the Maxwell equations or so on, that this would just fall out. Good. There, everything is nice. For special relativity, everything is nice. The constructive theory version and the principle theory, they match very well together. The other case that's not so nice is thermodynamics and its relation to statistical mechanics, because then you start with this kind of theory is kind of the history of the theory is kind of interesting, because it was more like an engineering approach, or more like engineers they had to solve specific questions about how you convert heat into work and so on. And then you have these kind of underpinnings with statistical mechanics, and then it turns out, wait, these principles are not 100% right. So we have then to revise these the principles, especially the second law. And then we say, actually, the constructive theory is the better one in this case, because it just makes it more precise and revises the principles. So yes, that's the kind of historical or the background, and still, I think I haven't seen really thermodynamics as an example to justify that. Of course, it's more like special relativity, given certain physicists or philosophers who work on that, they are more or less open to say, okay, we can add actually a constructive base and then try to have, I don't know whether they would say it's like a constructive theory, but at least a kind of ontological story, what is going on. So Loyola is also a physicist who justifies or just say that the quantum reconstruction program gives us, some kind of incomplete quantum theories, and then we have to do some metaphysics to add to that. Yeah. Mm-hmm.
Okay, the last question.
Thanks. Can you go back to the slide with the kind of diagram, the Venn diagram?
This here, yeah.
One thing, maybe it's consistent with that diagram. One thing I think is important to emphasize, if you're thinking about some of the agential views, especially Healy's view, but maybe cubism as well, is that the quantum state is not descriptive, it's prescriptive. I think Healy's the most clear about this. I think Cubist should say that, but anyway, so that means it's not describing agents, it's not describing anything. It's not describing constant states. So in some ways, it's sort of none of the above, right? And if you kind of take that seriously, if you understand quantum theory as a normative theory or a prescriptive theory, then the kind of explanations you might expect are going to be different. So, this is a problematic example for some reasons, but think about subjective probability theory. If you think about it that way, if you think about probability theory in a subjectivist way, it doesn't represent anything in the world. It doesn't have an ontology. You can apply it to anything. Why should we obey it? Why should we follow the guidance of, follow the probability axioms? Well, maybe give like a Dutch folk argument or something like that. So I'm wondering if that's a helpful way to think of the quantum reconstruction principle. That they're looking for an explanation like that. That says you must do as quantum theory says in this kind of normative, prescriptive way, because, and then you give some principles, which is very different than like an ontic type story, which in the probability case would be, these are the objective chances, and then, Lewis's principle or something. That's not what they want, right? They want this other kind of story that says you must follow the quantum prescriptions for the reason given by this principle. Does that sound plausible?
I think some of the theories that are in that corner here, I think yes, I think there are something along these lines. I mean, there are Cubism has this kind of subjective probability interpretation built into the theory, and I think this is what some of these theories in that box fit in. I'm not so sure about pragmatism or Healy's approach. The way that I phrase it would be even outside of all of that.
Yeah.
But maybe if there's a way of saying, I can justify a pragmatic approach through some specific principles or so on, then I can derive that. Then it can fit probably here. But how I understood it was like, if you're pragmatic, you say, okay, I just use this what I have, and it's somehow useful and it's good. So I would even put it even outside of all that. But Peter disagrees. That
I think it's like legal. That we can talk about that.
I see. But the thing is here. I think it's pretty clear. It's like creedal. You have to be a super determinist.
Oh.
Yeah.
Okay.
I think that's the only. Yeah. Because there's no other way if you're psychedelic. So therefore, I think that's it would be interesting where the pragmatist theory would fit in there. Yeah. Thank you. Yes, let's do that.
Okay, Thomas, thank you again for your talk and for the discussion.